The laws of Newton affect us and everyone around us. They are present in the most simple things. Sometimes we don't remember that they exist. They can be when you push a box, when you throw a ball, or when you are playing with marbles. Also, when you are in a fair and you want to play with bumper cars. But what exactly happened that caused these kind of reactions in these objects? In the workshop, we want to demonstrate how the third law of Newton affects daily life with a very interesting point of view. Also to demonstrate how fun is to learn about physics with interactive activities that are easy to do and to follow. We expect that with this workshop you will know more about one of the laws of Newton.
General objective. We are going to deepen in the study Newton's third law that Sir Isaac Newton did in 1867, taking account the points concept, definition, and the sector that this law is talking about. We will promote its basis and the way in which this law is related to our day-to-day. We are going to represent this topic in bumper cars to explain how this law is commonly everywhere and the way it graphically works. Also, we are going to give common examples to clarify the idea. Specific objective. We will be representing this law in bumper cars, how it works, in what consists, and the relationship with this law. The main idea is to give an example of this law in something simple but have a background on it. To do this, we made a workshop as a representation with images and specific explanation. In the workshop, we will be explaining to you how we made the bumper car and do the experiment to get the final result.
Born in Lincolnshire, England, in 1643, in a peasant family. In 1661, when he was 17 years old, he began his studies in the Trinity College, and 3 years later, on 1664, he started thinking about leaving a mark on the mathematics. Among his discoveries, we can talk about the principle of differential and integral calculus, investigations about the light, and the fundamental laws of physics. He was professor for many years, specific 13 years, but he left the post to become director, and in 1705 he was elected president of the Royal Society. In 1727 he died because of unknown disease. Talking about the Newton's law, specifically action-reaction, an example that we can have in our day-by-day is the one when we drive a nail and also when we are playing in a swing.
The English physicist, mathematician, and astronomer Sir Isaac Newton depend on the studies of Galileo and Descartes, published in 1684, the first great work of physics, Mathematical Principles of Natural Philosophy, also known as Principia. In the first of the three parts into which the work is divided, he exposed the relationship between forces and their dynamic effects in three laws. The laws of dynamics. Starting from his studies, Newton developed dynamics, a science that deals with the relationship between the forces at the moment that originated. In the second section of the Mathematical Principles of Natural Philosophy, he published, at the insistence of his great friend and astronomer Edmund Halley, Newton established, after a series of definitions, the three axioms or laws of movement.
And I'm going to explain about the third law of Newton, and I'm going to give some examples of it to explain it better.
This law says that every action has a reaction between two objects. It suggests that these forces occur in pairs which magnitudes and directions are equal and opposite. To demonstrate this, the balls crashing is the action, and the reaction is the balls changing their trajectory, as we can see, and then they are going to falling down. As we can see in this image, the rocket is going to eject fuel, and this fuel is going to hit the ground, and the rocket is going to elevate because it's going to boost the rocket to the sky. In these examples, we're going to see two balls that they are going to crash at the same time. First of all, this is the action, where the balls are going to crash, and the reaction is going to be that they are going to stop and they are going to suffer a change of velocity.
About the application of the third law of Newton in bumper cars. Well, this law talks us about action and reaction in the bumper cars. This is applied when the cars crash. Well, imagine that this car and this car, well, they are at, well, they have the same speed and they directly crash. Well, uh, this law is applied where if both cars crash, they are not, well, the force that they have will be annihilated, and well, the cars will stop just like this. That's, well, imagine that this car is going like this and this one uh, crashes like this, obviously because this car don't have a force in the way, in the same, well, in the opposite way that this car is going to be pushed, and this is going to be like the winner of that crash, just like this. And well, that's basically the way the third law of Newton is applied in the bumper cars. Thank you.
This experiment you will use scissors, wood sticks for bottle caps, a straw, of plastic tubes, a plastic bottle, Sharpie, a balloon, glue, a screwdriver, color markers if you want to decorate the car, and Durex. For the first step, you need to peel off the label of the plastic bottle and mark 4 dots with a Sharpie in each side of it as is shown in the video, because after that you will take the screwdriver and put it over the oven for heat it up, because this action will allow us to make holes into the bottle, and of course we are going to repeat this step in all the dots of the container. The next step is to break the wood stick and straws into two, so you can check where are going to be the holes, and also make another dot for the screwdriver and the stick that will pass through them with the help of glue. So while they are drying, do another sign at the end and top of center of the flask, because once again we are going to make a space into there or the tubes, where in the end of it will be a balloon sealed with Durex. Also, don't forget to do a taster for checking if the balloon or straws aren't broken. After that, grab your bottle cap, put it through the other holes towards adding the other piece with more glue, and like this is how the bumper car should look like. Don't forget that you can do how many you want for crushing them with each other, or dash it with the wall, as I did, because the balloon will be the stopping method our car is using.
For every action, there is an equal and opposite reaction. When one car hits another, it is simultaneously receiving a blow that propels it backwards. It doesn't matter if one of the cars is stopped. It exerts the same force on the car that just hit it. Both cars and passengers conserve their kinetic energy by making a type of rebound that does not alter bodies. If two bumper cars traveling at the same speed and carrying the same amount of weight run into each other, they will bounce off and move an equal distance away from each other. However, if there is a difference in the amount of weight being carried in the two cars, the car with less weight will get bumped farther away from the point of impact than the car carrying more weight.